Okay, so let's consider the sequence here, the infinite series. Sum as k goes from 1 to infinity, of minus 1 to the k plus 1 of k, sine of 1 over k. So the first thing, alternating series, again, had really three conditions. Condition 1 is that our terms need to be positive, needs to be non-increasing, and the limit needs to go to 0. Okay, so first of all, these terms are positive. So we can check the non-increasing idea, or we can just go ahead and look at the condition first. Let's look at the limit condition, because if that doesn't go to 0, then the rest of the stuff doesn't matter. We don't even need to bother checking the other stuff. Okay, so if it doesn't go to 0, then we just stop and we're done. We don't care whether it's increasing, non-increasing, decreasing, whatever. So we just check to see, does the limit of the underlying sequence go to 0 first? Okay, so let's do that, and then if it does go to 0, then we'll approach the question of, is this thing non-increasing? In other words, is it a decreasing sequence for the most part? Okay, so we'll come back to that question if we need to. So the limit is k goes to infinity of k sine of 1 over k. So we quickly realize that this is an infinity times 0 limit. An infinity times 0 limit. Okay, so remember how to handle an infinity times 0 limit. We take one of these things over the reciprocal of the other. So in this case, I'm saying x here, and I should be saying k. Hold on, let me fix that. So you're used to writing it as limit as x goes to something. So k, so one of those things, sine of 1 over k, divided by 1 over k. And at that point, that gets me. Okay, sorry there, I just had a phone call come through, so I had to pause the video. So I believe we're at the point of realizing that this is a 0 over 0 limit now. Sine as k goes to 0, 1 over k goes to 0, sine of 0 is 0. And of course, as k goes to infinity, 1 over k goes to 0 as well, so it's a 0 over 0 limit. So we're able to invoke L'Hopital's rule. We're able to invoke L'Hopital's rule. So limit as k goes to infinity. Okay. For sine, we do the derivative of sine. That would be cosine of 1 over k times the derivative of 1 over k, which would be minus 1 over k squared, divided by the derivative of 1 over k, which would be minus 1 over k squared. So our limit simplifies as k goes to infinity of cosine of 1 over k. Cosine of 1 over k. And as k goes to infinity, 1 over k goes to 0. Cosine of 0 is 1. So this underlying sequence is approaching 1. And so therefore it diverges. Therefore it diverges. And I don't even have to bother about worrying about, is k sine of 1 over k, right? Is that thing a non-increasing sequence or not? Because the limit idea never mattered. So it never materialized. Actually, turns out this is actually an increasing sequence. If you were to look at the graph of k sine of 1 over k, you'd actually see that this is actually an increasing sequence. It increases towards 1. But again, we don't have to bother checking that. The first thing we want to look at is the limit. If the limit's 0, then we'll worry about, is that other condition met? If the limit's not 0, then we don't have to worry about the other stuff. Okay.